Okay, Math 9, here we go. This is our last section. Section 7, we're going to look at graphing. So we're graphing straight lines in this grade, and it's all two-dimensional space, so let's get after it. Here we go. Now, it's really important first to identify the fact that these lines exist in two-dimensional space. This is our x-axis. It's basically a horizontal number line, travels left and right. This point right in the middle, that's what we call the origin. And it has coordinates, x coordinate 0. I have not moved left or right. Okay, and then the vertical axis is called your y-axis, and it is a number line that travels up and down. So that origin is at 0, 0. I have not moved anywhere. And every point is plotted as an x, y. The x coordinate comes first, so where do you exist horizontally? And then where do you exist vertically? And in order to exist anywhere on this grid, you need to have two coordinates. So if I were to exist right here, well, how did you get there from the origin? You traveled over 1, 2, 3, 4. So you exist at 4 on the x-axis, but you exist up 2 on the y. So you exist at 4, 2. That is your x, y coordinates of the point. If you exist, say, here, well, how did you get here? Well, you moved -6 on the x-axis and then +5 on the y-axis. So every point will have two coordinates. They will have a x value and a y value coordinate. So what if I existed right here? Well, I have moved -3 along the x-axis, and I have moved -3 down the y-axis. So I exist at -3, -3. So every point will have two coordinates, okay? Now let's do one more. What if I exist right on the x-axis? Well, you have moved to 8 along the x-axis, but have you moved up or down? No, so you have a 0 y value. So that is 8, 0. On that same note, if you were to exist, say, on the y-axis, here, this green one down here, right here, I have not moved on the x-axis, but I have moved down 7, -7 on the y. So every point is made up of 2 points, an x and a y coordinate. It's so very important that you understand that before you can do anything else, okay? So, slope. Now, this is probably one of the main aspects of grade 9 straight line is every line has a slope. And since it's a straight line, it has a consistent slope. And when you think about slope, you might think of a thing like a hill, like ski slopes, right? So the slope is the basically steepness, okay? Slope is your steepness. Now, how do you determine whether or not something is steep, right? Well, it's change in height. So here is a point here, and here is a point here. Well, between those 2 points, how quickly did it change in height? So 1, 2, 3, 4. It changed in height by 4. And what did it change in length? Well, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So its length changed by 10 units, and its height changed by 4 units. So when we're talking about slope, it is the change in height over the change in length. And depending on those values, you will get your slope. So in this case, we have a slope of 4/10. So I'll talk more about that on the next few slides, but you can map it out visually between any 2 points. You're basically creating a right angle triangle of your slope. You're going up or down and then left or right. And you're checking to see how quickly did you change in height versus how quickly did you change in length. And that will give you steepness. So if you look at it considering using 2 coordinates, well, what are the coordinates of these points? This is 5, 4, and this is -5, 0. So which slope is represented by the letter m? Which value is our height coordinate? Well, that is our y. And which value is our length coordinate? Well, that is our x. So what is the difference between these 2 points? Well, we just need to subtract the y values and the x values of the 2 given points. So we get this equation, y2 minus y1 over x2 minus x1. And before you get all freaked out, all the 1's and 2's mean are 0.1 and 0.2. So we would say that this would be our point let's say point 2, and this would be our point 1. Okay, so what is the y value of point 2? Well, the y value of point 2 is 4. And what is the y value of point 1? Well, it's 0. And what is the x value of point 2? It is 5. And then be careful because it's minus, but then what is the x value of point 1? It is negative 5. So that is the mathematical representation of the change in height over the change in length. And if you do the subtraction, you end up with 4 over 10. It's exactly the same as what we got here, but we can do it using this equation. Change in y's over change in x's, which is change in height over change in length. Now, let's just talk for a second about direction of travel, because you can map your slope from anywhere you want. I'm going to use a black line so we can see it. So let's just say I have a point right here, okay? And I have another point right here. Well, how do I get from one point to the other? Well, you can map it using a direction of travel. Now, if you are moving horizontally, okay, so along the x, if you move to the right, you're moving in a positive direction. If you move to the left, you are moving in a negative direction. So this is a little bit of physics here, okay, because it adds direction to your travel. If you are moving vertically, well, if you're moving up, you're moving in a positive direction, and if you're moving down, you're moving in a negative direction. So just watch this. In order to get from the first point to the second point, I can travel this way. You can't see the yellow, so let me get a bit of a darker color here. I can travel this way in a positive direction until I'm directly below it. So I've traveled in a positive direction. Okay, and then from there I travel up and I get to my point. So I've traveled in a positive direction and a positive direction. So if you consider my slope as my rise over run, right? Slope m is my change in height over change in length. So rise over run. I have moved positive direction, positive direction. So I have a positive slope. If I were to move from the top point to the bottom point, I would move this direction, and I'd be moving in a negative direction this time. And if then I had to move down, I'm moving in a negative direction. So in this case, I'm moving negative over negative, but that still gives me a positive slope. So your direction of travel can change the sign of your direction, but your slope will always stay the same. And we'll see a few examples of these as we go on. But be very aware here. I'll erase and I'll do one more for you, okay? Let's look at it going the other direction. So imagine I have a point here and I have a point down here, and I'm going to connect them together. Well, if I start at the top, I'm going to move down, which is a negative direction, and then I'm going to move in a positive direction. So in that case, my slope would be a negative rise over a positive run, which would give me a negative slope. If I started at the top, I would move this way in a positive direction, but then I'm still moving in a negative direction down. So I'm still going to have a negative slope. So the direction just changes the sign of your run or your rise, but the overall effect will be the same. So let's map these slopes, okay? I want to know what the slope is of these lines. So I'm going to go, okay, from here I go down. 1, 2, 3, 4. So I've gone negative 4. And then I'm going to go over 1, 2, 3, 4, 5, 6. So I've gone positive 6. So my slope is negative 4 over 6. Now you can simplify that to negative 2 over 3, and you might look, well, if I go down 2 and over 3, yep, I'm on the line there too. So you can see by mapping it, you get a negative and a positive, so it gives you your negative slope. If I map the next one, I'm going to go positive direction 2, and then a positive direction 6. So I have a slope of 6 over 2. Now, again, you might be like, well, wait, that's just 3 over 1. So yeah, if I went over 1 and I go up 3, yep, there it is 2, right? Your slope is consistent. But you can see that the mapping gives you your positive or your negative values. So what's the y-intercept then? The y-intercept is the point the line crosses the y-axis. So this point right here has coordinates 0, 5. Every time we cross the y-axis, you got to think every single point on the y-axis has an x value of 0. And that's a very important feature as we move a little bit forward. But the y-intercept is just that, 0, 5. Here, what's the y-intercept of this line? It's 0, -4, because it crosses at 0, -4. We call that point the y-intercept. Because we get this lovely equation called the slope-intercept equation, where you'll see equations written in forms like this. Y equals 2 over 3x plus 5. Y equals -3 over 5x minus 2. You'll see questions like this all the time. You'll see, okay, that is the equation of a line. And M, the letter M, is your slope, and the letter B is your y-intercept. So if you look at this equation, what's the slope of this line? It's 2 over 3. It's staring you in the face. This equation tells you there's your slope. And what's the y-intercept? Where does this line go through the y-axis? It tells you right here at 0, 5. So this equation is awesome because it gives you that information. So here, what's the slope of this line? It's -3 over 5. It is telling you right here, that is my slope. Now here you'll notice it's a -2, and in the equation it's a positive b, but -2 just means plus -2. So my y-intercept in this case is 0, -2. So from that equation, you can get the information of this is my y-intercept, this is my slope. So you could plot the y-intercept, and you can trace the slope, and you can draw the line, and we're going to look at that later. So there's some special pieces of, straight line lore when it comes to vertical and horizontal lines, because if we think about the equation y2 minus y1 over x2 minus x1 for my slope, look at a vertical line, okay? So this is point 7, 4, and this is point 7, -4. So if we threw that into the equation, right, we would get 4 minus -4 over 7 minus 7. And all of a sudden we get 8 over 0. And that's no good. Okay, we cannot divide by 0. So a vertical line has what we call an undefined slope because we can't divide by 0. And if you think about it as a slope itself, there's no slope there. You can't ski off that. You're going to fall to your death. Okay, it is a vertical sheer drop off. There's no slope. Now, if you take a horizontal line and we do the same thing, y2 minus y1 over x2 minus x1, and we look at these coordinates, we have -2, 4, and we have 7, 4. Well, if we throw it into the equation here, we're going to go 4 minus 4 over 7 minus -2, which is going to give us 0 over 9, which is 0. 0 divided by anything is 0. We're allowed to do that. And think about that. If you were skiing and you were on a flat surface, there's no slope, you're not going to move. Okay, so you have a 0 slope. That is a 0 or the number 0 slope. So horizontal lines have the slope of 0, vertical lines have the slope undefined. They're two special cases for straight lines because these are our 4 different types of slopes that I've touched on briefly. Just consider the fact that this one, when we mapped it, we're moving up positive and then right positive. It had a positive over positive slope. And just for kicks, if you wanted to map it the other way, if you wanted to map up here, right, we did this, it'd be negative over negative, which is still a positive slope. So if you're traveling from down to up, from left to right, so if you're going in this general direction, you're a positive slope. If you're traveling in this general direction, you are a negative slope from left to right. If you're a horizontal line, you got a 0 slope, and if you're a vertical line, you have an undefined slope. Those are the 4 different types of slopes you can have of a straight line. So the last thing we want to look at is a point a solution to an equation? So what it means is the point on the line? So this is the equation of a line in slope-intercept form. Y equals 2x plus 5. It has a slope of 2 and a y-intercept of 5. But what this question is asking is, does this line go through the point 1, 8? So if you think about this graphically, you have a point kind of up here, 1, 8, and you want to know if your line goes through it. But you don't have to graph it. because what it means, what the x and y in the equation mean, they represent any xy coordinate of any point that exists on that line. So what you can do is, remember, this is an x comma y. You can plug those values in for these values here. And then you just check to see if the equation stays true. So what it's saying is, when y is 8, because here I have an 8 as my y coordinate, x is 1. So I've subbed in the x and y for this x and y. And then I just check to see, okay, 8 equals 2 plus 5, 8 equals 7. Well, that's not true. And since that's not true, it means it is not a point on the line. And in other words, since we're dealing with an equation, it is not a solution to the equation. So let's look at one more. Okay, here's my point, 10 comma 2. My 10 is going to plug in there, and my 2 is going to plug in there. And what it means is, when y is 2, x is 10. And if that's the case, is this an equation to, or a solution to the equation? So here, 10 divided by 5 is 2. So 2 times negative 2. So 2 times negative 2 is negative 4. Negative 4 plus 6. 2 equals 2. Yes, that's true. So yes, I am a solution. I am a point on the line. I exist. So there's a lot going on in this section in this booklet. I really, really recommend you watch this video again, but you also watch it while going through the notes so you can really tie these concepts together. And then we're going to be flying into graphing straight lines. Graphing straight lines are going to come back at you again in grade 10, grade 11. So really, really try your best to get as comfortable and confident as you can with this topic.